Some questions they like to ask include, how many ways can we get from point A to point B? So if you think of this sort of like a city map where this is a road network, okay, so one block east, one block south. If we can only move east or to the right and south or down, let's say, from A to B, how many ways can we get from point A to point B becomes the question. So this would be one way, this would be another way, and so on. So how many ways can we get from A to B? Well, this actually works out like a permutation or factorial type notation as well, where we got a 1, 2, 3, 4, 5, 6, 7, 8. So 8 factorial is how many paths or how many choices we have to get from A to B. So we have 8 different choices to make, but 3 of them are down, and 1, 2, 3, 4, 5 of them are to the right. So the number of ways of getting from A to B ends up being 8 factorial divided by bracket, don't get the brackets, 3 factorial times 5 factorial, which is 56. So there's 56 different directions or different ways from getting from point A to point B. So if you have a perfect rectangle type grid system, 8 is the number of ways, or 8 is the number of intersections to get from A to B, and then we divide by the length, 1, 2, 3, and the width, 1, 2, 3, 4, 5 factorial for 56. The method to find the number of ways from A to B needs to be different if it's not a perfect rectangle. So let's say we've got a park or something in the middle here, and we can't give directions through the park. So how many ways can we get from A to B? Well, if we think of this in terms of intersections, then in order to get from A to this point, there's really only one way to get from here to here, is just to go down. And there's really only one way to get from here to here. But if I said how many ways to get to here, well, you could go this way or you could go this way. So there's 2 ways to this intersection. And we can always get that if we add up these 2 diagonals. So 1 and 1 make 2. Let's look at this node here. If there's 1 down to here, there's only 1 to this intersection. There's only one way to get down here, and there's only one way to get across the top. You just keep moving to the right. So to get to this intersection, 1 and 2 must make 3. 3 ways coming down here, 1 way coming across here, that would be 4 ways when you add the diagonals. And if there's 4 ways coming down here and 1 way coming across here, there'd be 5 ways to that intersection. And we can continue this across the top. 2 and 1 make 3, 3 and 1 make 4, 4 and 1 make 5, 5 and 1 6, 6 and 1 7. And if there's 4 ways to this intersection, and there's only 4 ways to here, and 4 ways to here. And if there's 5 ways coming down this way, then we've got 5 ways still here. And at this intersection, we finally got another diagonal to make 9 ways to get to this node. And we just keep working our diagonals. 13, 9 and 13 is 22. Let's go back up here for a change. 5 and 6 make 11. 7 and 11, this diagonal is 18. 9 and 11 make 20. 20 and 18 make 38. 20 and 22 make 42. And 38 and 42 give a grand total of 80. Okay, so you start up here at A, put a bunch of 1s down the left side, a bunch of 1s across the top, and start working your diagonals until you get the grand total at B, which in this case is 80.